Hello everyone. Today we'll be covering the last part of electromagnetic effects of CIE IGCSE physics, and that is the working mechanism of a transformer and like calculations involving transformers. If you haven't checked out my previous parts of electromagnetic effects, I suggest you do because it primarily uses the phenomenon of electromagnetic induction as a foundation for its mechanism. So this is a simple diagram of a transformer that we provided. You'll never be given like a complicated diagram, even in A levels, like if you do take physics in A levels, for transformers. So this is like a very basic diagram, pardon the bad drawing. And the base here, like this is of conducting material, this thing, the thing that transmits the voltage indirectly, or voltage, current, EMF, whatever term you use to describe it. This is the thing that indirectly transfers it to the secondary coil. So there's some labels that you have to know here. First and foremost, this is the primary coil. This is the secondary coil. Pardon that. Okay, so this is the secondary coil. And if you know your notations right, you will know that this is an AC supply. Now I'll get into why this is an AC supply and not DC. So if you remember from your AC generator, from the lesson of AC generators, and of like how an AC, like alternate current AC supply works, it supplies EMF like this. And from your electricity lessons, you will know that V is equal to IR, and therefore voltage is directly proportional to the current. Okay, and EMF is basically voltage, but like the maximum possible voltage. And from the first lesson where we mentioned, this is not a formula that you need to know, I just use it to explain the phenomenon better. So B is equal to mu dot I by 2 pi R. Okay, so you'll know that the magnetic field strength is directly proportional to the current that goes like across the wire. Okay, so in a way, the EMF, again, in a way, I'm not saying that they are directly proportional, but in a way, the EMF is directly proportional to the strength of the magnetic field. Okay, so over here, okay, the working, now I'll get into the working principles of a transformer. So what happens is when the current goes around the coil, recall from the first lesson that when a current goes around the coil, it induces a magnetic field. Okay, of whatever direction. That is not important here. I mean it is, but for explaining the mechanism, it isn't really. So that goes around the coil. Okay, and when the current goes around the coil, it induces a magnetic field. And because this is a conducting material, you should remember that if a conducting material is used, what happens is it also gains a temporary magnetic field. So when it's in contact with the magnetic field of the primary coil, this also gets magnetized. And when this gets magnetized, by varying strengths. Okay, no. First, I'll explain like the magnetic field strength here. So let's say from here to here, okay, this point, from this point, the initial to the midway point there. Okay. So the strength of the magnetic field would be like this. It would increase from 0 to this much. Okay. And let's say from this point to this point. I'll use a different color for this. Give me a minute. So from this point to this point. So it would increase like from nothing to this much, right? So it would increase from nothing to this much. So when it does that, this magnetic field strength is temporarily induced onto this material. And when this material gains this temporary magnetism, it also has that effect here. So you'll realize that when it induces that magnetism at all points, what happens is this magnetic field lines, it cuts through, or there's a change in magnetic flux in the secondary coil. And when there is a change in magnetic flux, you will recall from your electromagnetic induction that it induces an EMF. So indirectly, the primary coil induces an EMF on the secondary coil, right? And that EMF is used to power something directly. And obviously there's something in between like a capacitor and whatnot, but let's not get into details. Let's just assume it directly powers something else, okay? And in our syllabus, we'll have to assume, or we're always given, that every transformer is 100% efficient, right? They're basically ideal. What I mean by this is that you can assume that when there's like the EMF or the current in this induces a magnetic field, and the magnetic field is induced onto this, and then this magnetic field is cut through here, there's obviously like a decrease or like a loss in energy, either to heat or just lost somewhere here and there, because that is what the law of conservation of energy is, right? But in your calculations and your specifications, you can assume that it's ideal, that there is no loss of energy, that whatever energy is delivered from this region is all of it is being delivered to the bulb. Okay, so you can assume that it's 100% efficient. Now, there are two formulas you need to know when it comes to transformers, and the two formulas are N1 by N2 is equal to V1 by V2. Okay, N1 by N2 is equal to V1 by V2, where N is equal to, or N basically signifies the number of turns of coil. So like in this case, let's say N1 is equal to what, 100, and N2 is equal to what, 200, right? And let's say the voltage supplied here is what, 2 volts. So what is the second, like the voltage that's received by the bulb? You can calculate using this formula. So you make V2 the subject of the equation. So you just make it V1 into N2 divided by N1. So this would be, so V1 is 2 times the number of turns in the second coil, 200, divided by the number of turns in the first coil, which is 100. So the voltage delivered will be 4 volts, right? And we are assuming that no energy is lost. And on the same note, like assuming no energy is lost, what we can also assume is that power from coil in the primary coil is equal to the power in the secondary coil. And P is equal to VI, therefore V1 I1 is equal to V2 I2. This is your second formula that you need to know for transformers. And using this formula, using like a combination of both these formulas, they go hand in hand, you can tackle like the current in the primary or secondary coil, or the number of turns of the primary or secondary coil, and the voltage of the primary and secondary coil. And that is all you need to know for transformers. If you have any doubts, please do leave them in the comment section below, and I hope you understood.